All right, section 5, multiplying and dividing rational expressions. Multiplying and dividing rational expressions is going to be a lot like multiplying and dividing fractions. So if we have something like 1/2 times 3/4, when you multiply, you just multiply straight across. So 1 times 3 makes 3, 2 times 4 makes 8. We're going to be doing the same thing here. You multiply straight across, numerator times numerator, denominator times denominator. You simplify and cancel. Now, because we're going to be using rational expressions, always factor if you can, and then divide out factors from the numerators and the denominators. Now, the good thing about after you factored your rational expressions, you can cross-cancel from one fraction or one rational expression to the other. And we'll see how that looks in some of our examples here. Our first example, we've got 8 over 6x times 10x over 8x squared. Now, our steps here said just do numerator times numerator, denominator times denominator, then simplify and cancel. This is how that would look. Numerator times numerator, 8 times 10x becomes 80x. Denominator times denominator, 6x times 8x squared. 6 and 8 makes 48. X and x squared makes x cubed. So this would be after we just multiply numerators and denominators. Now we'd have to look and say, okay, x cancels out with an x. So this one goes away. This becomes x squared. And 80 and 48, I can take 16 out of each of those. Take 16 out, I'm left with 3. Take 16 out, I'm left with 5. So on top I have 5, on bottom I have 3x squared. So 5 over 3x squared. So that's one way to do it. Multiply everything across first and then simplify. It might be easier though to simplify first. Okay, so you kind of simplify as you go. 8 over 6x. I can take 2 out of each of these. So this 8 becomes 4. This 6 becomes 3. I have 10x over 8x squared. I can take x out of each of these. That squared goes away. We're just left with x here. X is gone. 10 and 8, I can take 2 out of each of those. This 8 becomes a 4. This 10 becomes a 5. So now it's 4 over 3x times 5 over 4x. Now, good thing again about multiplying our fractions or these rational expressions, we can also cross-cancel or cross-divide out. This 4 cancels out with this 4. So the only thing left on top is this 5. What we have on bottom, 3x and x, 3x squared. Just like this, 5 over 3x squared. So you can do it either way. You can simplify beforehand and then multiply, or you can multiply everything and simplify afterwards. Either way, you'll get to the same answer. In our next one, we've got 4 times 2 over 10n squared. Now, right now, this looks like a whole number, but remember, any whole number, you can make a fraction by putting it over 1. So it's 4 over 1 times 2 over 10n squared. Looking first at 2 and 10, we'll cross out and make it 5 and 1. Took 2 out of each of those. So now 4 times 1, multiplying right across, makes 4. 1 times 5n squared makes 5n squared. Nothing else can simplify, nothing else can cancel out. So that is our new reduced or simplified rational expression. All right, now things are going to get a little trickier. We've got 5b cubed minus 50b squared all over b minus 1. We've also got, we're multiplying by 2b plus 5 over 10b cubed plus 25b squared. Trick with this one is we want to factor everything first. This piece we can't factor, it's already done. This piece we can't factor, it's already done. But if we look at this numerator, we can take 5 out of each of these, and we can take b squared out of each of these. When we do that, our first rational number is going to look like this. 5b squared came out, and we were left with b minus 10. So these are our factors then on top, all over just this one factor, b minus 1. Over here, the top of 2b plus 5 had to stay. Let's look at what we can take out of these ones. 10 and 25, we can pull a 5 out of each of those. And we can take a b squared out of those two. So our bottom piece, or our denominator over here, becomes 5b squared, and then 2b plus 5. At this point, we start canceling things out or dividing out our factors. 2b plus 5, 2b plus 5. 5 cancels out with 5. B squared cancels out with b squared. So really, this factor and this factor are all we have left. So we'd say our simplified factors then, or our simplified rational expression, is b minus 10 over b minus 1. And that would be it. All right, this is where things get even more tricky. We've got 20x cubed minus 70x squared all over 6x squared minus 3x minus 63. That rational expression is multiplied by 3x squared plus 39x plus 90 all over x minus 2. First, we need to look at our two trinomials. This one has 3 terms, 1, 2, 3, so it's a trinomial. This one is a trinomial. When we're working with things with 3 terms in them, we have to use our AC method to factor these. So we will start with this one, 6x squared minus 3x minus 63. We can first factor out a 3 from all of those. 3 comes out of each of these terms, so we're left with 2x squared minus 1x minus 21. Now, just with these 3 pieces, we do our AC. A times c, 2 times negative 21. I'm going to write it off on the side, becomes negative 42. So we're thinking, what are the factors of negative 42 that would add up to negative 1? Well, those are going to be 6, positive 6, and negative 7. So we rewrite this trinomial of 3 terms as this polynomial of 4 terms. The positive 6x and the negative 7x would combine to negative 1x. Now from here, we just factor by grouping. Here is one group, here is our other group. So that first group we can take 2x out of, and it leaves x plus 3. The second group we can take negative 7 out of, and it becomes x plus 3. So our factors then are 3, stays on the outside, x plus 3, and 2x minus 7. Those are the 3 factors of this trinomial here. Now we have to deal with this trinomial. We can take a 3 out of each of those. It leaves x squared plus 13x plus 30. So now we have to do AC. A in this case is 1. There's 1 in front of this x squared. 1 times 30 is 30. So we're thinking, what are the factors of 30 that would add up to 13? And those are, of course, going to be 10 and 3. So 3 stays on the outside like before. X squared plus 3x plus 10x plus 30. These two, the 3x and the 10x, would add back up to 13x. Now we factor by grouping again. Here is one group, here is the other group. Out of our first group, we can take x. So x comes on the outside, and we have x plus 3. Out of this second group, we can take out 10, and we're left with x plus 3. Notice x plus 3 and x plus 3. So what are our 3 factors then? 3 on the outside, x plus 3, x plus 10. So we know what we need to replace this bottom piece with and this top piece over here with. Those are our factors over here. This piece, though, the top, we also need to factor. This is how it would look. We would take 10x squared out of both of these terms. That would leave us with 2x minus 7. The 10 times 2 makes 20. 10 times negative 7 makes negative 70. X squared times x is x cubed. And x squared with no other x's keeps this x squared. So now this piece is our new first rational expression. This one, we've already factored the top. The bottom has to stay as just x minus 2. That's the only factor there is. So now you can see we've got our two factored rational expressions. Now all we have to do is cancel out any factors that repeat. So we have a 2x minus 7 on top, 2x minus 7 on bottom. Those will cross out. X plus 3, x plus 3. Here we have a 3, here we have a 3, and I think that is it. Those are the only ones that will cancel out. So what are we left with? 10x squared, x plus 10, those are the only ones on top, and x plus 2 is the only one on bottom. So this would be your simplified rational expression. Dividing rational expressions. Dividing is going to be pretty much the same as multiplying, but we multiply by the reciprocal of the second fraction. So again, always remember to factor and cancel. Remember, reciprocal means flip the second expression. If we were looking at regular fractions, so 1/2 divided by 3/4, it would need to change. 1/2 stays, but it become times 4/3. Okay, we got rid of the divided by, we call it times, or multiply, and we switch these two around. 4 comes on top, 3 comes on bottom, and we would have 4/6, which could reduce to 2/3. Okay, so again, we're doing the same thing. Dividing by means multiply by the reciprocal. So we've got 5p squared over 6 divided by 7p cubed over 8. Because this is a divided by and we want it to say times, we have to flip these two around. We put the 8 on top and the 7p cubed on bottom. Now we can just cancel or simplify things as we did before. P squared takes 2 away from here, so we just have p on bottom. Out of the 6 and the 8, we can take 2 away, so we have 3 and 4. And I think that's it for simplifying. So now we just have 5 on top and 4. Those would multiply to make 20. Over, we have a 3 on bottom and 7p. 3 times 7 makes 21, still multiplied by p. So this would become our simplified rational expression then. So again, dividing means multiply by the reciprocal. Turn it to times, flip these around. Let's look at another example here. We've got division, change it to multiply, flip these around. 8/7x. So we can just get rid of this. Now we just cancel like before. This x squared cancels out with this x. So it's just x here. But we have another x here. This x will take care of that other x. So there's no more x values here. 8 cancels out with 8. Looks like a 1 and a 1 here. 1 times 8 is 8. 1 times 7 is 7. So our simplified and reduced rational expression is just 8/7. 8/7. Alright, things get a little bit trickier here. We're still dividing by, which means we need to change it to multiply and flip the fraction, or the rational expression, should I say, but this doesn't look like a rational expression. We just have a whole number here. So we need to put it all over 1. That'll help us when we're trying to flip it around. So to change it to multiply, I'll do that over here actually. You flip it around. So call it times and flip these two. This first one, we want to factor like we did before. This top piece, we can take 2 out of each of these. So we have 2 on the outside, a minus 8 over 2. Now, we cancel out factors, 2 and 2. So it's like we have a 1 here in each case. And that's really all that can cancel out. So 1 times a minus 8 times 1 means the top is just left with a minus 8. 1 times 8a squared means the bottom is just left with 8a squared. Now these two can't cancel out, this a and the 8 and the 8, because this is a minus 8 all as one factor. You have to think of this as its own number. So the only thing that can cancel this out is another factor of a minus 8. So these are not the same thing. They can't cancel. This would be your final answer. All right, this is going to be our last example, but it is going to be a little longer. Here we have 12v squared plus 12v all over 7v squared plus 61v minus 18 divided by 12v squared plus 12v all over 20 minus 70v. Because this piece is a trinomial, right there, we need to make sure that we do the AC factoring to get rid of it. So, start with 7v squared plus 61v minus 18. We have to do AC. 7 times, I guess that'd be negative 18, is negative 126. We need the factors of negative 126 that add up to 61. So again, you can write them all out or guess and check, or maybe just have a lucky guess. In the end, you'll find out that those factors are going to be negative 2 and positive 63. Okay, those two will multiply to negative 126. They'll add to 61. So from here, we start factoring by grouping. Here is one group, here is the other group. Our first group, we can take v out of, and it leaves 7v minus 2. Our second group, we can take positive 9 out, and we get 7v minus 2. So, 7v minus 2 happens in both cases, so it looks like our factors are going to be 7v minus 2 and v plus 9. This here, these two factors, will replace the bottom. That goes right there. What replaces this top piece? Well, we can take 12v out of both of those, and it would leave v plus 1. So our first rational expression looks like this now. Our second one, remember, has to flip. These two have to flip, and we have to factor them. So when we have 20 minus 70v, what can we take out of each of those? 10, and it leaves 2 minus 7v. When we have 12v squared plus 12v, what can we take out of both of those? Again, remember, we're moving it to the bottom as well. We take out 12v and v plus 1. So at this point, now is when we can start canceling things out. v plus 1, v plus 1, 12, 12, v, v. And that's pretty much everything we can cancel out at the moment. So right now, it looks like we have 10 times 2 minus 7v all over 7v minus 2 times v plus 9. Now at this point, we might be tempted to say, everything is done, we can't do anything else. But we need to recognize 7v minus 2 is the exact opposite of 2 minus 7v. So how can we change these so that they're the exact same thing? We need to factor something out of this. We need to take out a negative 1. Negative 1 times what would make this back to a 2 minus 7v? Well, when you factor out a negative 1, it changes these signs. So this is now a negative 2. This is now a positive 7v. When these change, this is positive and this is negative, we can move them around now. The 7v can come to the front, and the negative 2 can come to the back. Now, I'm going to put a times here. because it's 10 times this factor and this factor. Now, 7v minus 2 matches with 7v minus 2. So we can cancel those out. So what's left on the top? 10 times negative 1. What's left on bottom? V plus 9. So this would be our final factored simplified rational expression. The negative 1 times 10 made negative 10, and it's still over the factor v plus 9. Now you only have to use this trick when you can recognize that these factors are exactly opposite of each other. 2 minus 7v and 7v minus 2. You factor out a negative 1 from one of them and it flips it around, then you can cancel those out. And that should be it for our video.